welcome to this talk, Open Source Analytics on MongoDB. Here is Aurélien Gervasi.
Hi, I'm a data scientist working for Octo Technology, and I'm working with Pierre-Alain Jachiet. We are both really fans of Python. We are using it a lot in our work, and also we are both fans of open source bricks and solutions.
So you said we are data scientists, but what is a data scientist actually? Is it like a data strategist, someone that controls the world of data? Is it like a crazy mathematician that built complex artificial intelligence with a machine learning algorithm? Not really, a bit, but most of the time, like what data scientists do is that they are analysts with developer skills that programs. And most of the time, what they really do is that they process data. In fact, when you think about the data science process, most of the time that you spend is to first identify the data, to know where you can find data, and how it's structured, then how you can access the data. Sometimes you have technical problems to access the data. Sometimes you have to scrap it or you have to transform it. And most of the time, really, you spend it to prepare it. And our talk is about when you start from MongoDB data, which is a bit fractal like that, and you want to analyze it. Or you go from this MongoDB data to your analytics classical tools, like here, business intelligence tools, that is Superset. Okay, so let's go. Our talk is about this rainbow. First, what is the point with MongoDB? As you may know, MongoDB is the leading NoSQL database. So if you compare several NoSQL databases, for example, you compare the number of people that put MongoDB in their LinkedIn profile to other NoSQL database, you can see that at the end of 2015, you had 2 million people that had this mention in their LinkedIn profile, which is 4 times more than Cassandra. So it's really a preeminent technology. And even if you compare to all database technology, you take the 7 most popular database technology, you can see that all of them are relational data stores. The 3 most common ones are, the most popular one are Oracle, MySQL, or SQL Server. Then you have DB2 and Microsoft Access that are a bit less popular. And then you have those 2 trending databases, which are PostgreSQL and MongoDB. And MongoDB is the only NoSQL one. And why many people use MongoDB? Is it because you have a lot of semi-structured data in the new world of data? Is it because you want to scale to bigger databases? Or is it because you want more performance for your analysis? Yes, all of those reasons are true. And also, many people use MongoDB because it's generally more natural for developers to use than relational databases. You can say that MongoDB for a developer is start to get started with, and it's really a pleasure to use. Why is this true? Because developers speak JSON. When 2 programs communicate, for example, through the internet, through an API, you have many JSON API. You can even say that JSON is a modern data exchange format. Usually it used to be XML, which is usually a little bit more structured with schema. It's also a document data format, but JSON is more and more current. And actually, MongoDB is JSON. You can store directly JSON in MongoDB. So in the end, we have MongoDB, which is a very common technology to store data. And if you look at the number, in 2015, you already had 10 million downloads of MongoDB with 2,000 paying customers. So lots and lots of data from many applications are stored with MongoDB. So far, so good. So you have this data stored in MongoDB. And time goes on, and a lot of data gets in. And like some boss hears in the news that big data is a new world, that you can create a lot of value with data, and he has a dream. And he says, okay, maybe we should analyze this data, create a lot of value from this data, and conquer the world. So he asks, please, an analyst for this data. An analyst comes in, and analysts are different kind of people than developers. And they start to speak with the database to understand what is the data inside, and they find JSON data. And usually, they are lost. Like analysts, when they are looking at NoSQL data, at JSON data, they are lost. It's not natural at all for them to analyze this data. And I would like to explain a bit more on this subject, because that's the main reason we have a problem here. Because lots of data is in MongoDB, lots of people ask to analysts to analyze this data, and they are usually, they don't have an easy way to analyze it. So the first problem for analysts when confronted with JSON data is that they are used to SQL. Analysts speak SQL. Here you have a simple SQL query. If you try to understand what it does, it gets this number of people in each state. And here you have all the MongoDB way to write this query, which is an aggregation. And for analysts, this is not natural to write a query like that. Analysts are much more used with the first form, and also their tool, like their analytics tool, don't speak the aggregation framework. They use SQL. So this is the first problem, the language. The second problem is that there is, like you can see, there is a division between developers and analysts. And developers like JSON. They like to speak JSON, they have JSON API, whereas analysts are used to work with tables. And developers like imbrication. Here you have a table, we have a collection of people who have cars, so they can have several cars. You have a list of cars here, and each car has a name and has tags text about the model. So you have an imbricated structure. And for analysts, this is really uneasy for them to work on this kind of data. They prefer table, and they prefer instead of imbrication, they like to have relations between tables that store the imbricated data. And the third problem for analysts is that developers, when they use MongoDB, they have a data model. They have a data model. So this is the application here. This is the application code. In here, you can have usually a model layer that stores a data model to interact with the database. And when you are in a relational database, you also have a schema. And analysts like to work with a data schema because this schema, in fact, is like an API to the data. A data schema is an API to the data. It's a map, so a way to understand how the data is organized and structured, and it's also a contract. If you have a column with a name and a type, in the schema, you can always know for the analyst that this column will be present with this type, and there will be no exception. And when you talk about MongoDB, you don't have the schema usually. So for the analyst, MongoDB being a schema-less database, you don't have a map. You don't know how this data is organized. You can try to find it. You can take a sample, look how it's organized, but you don't know, maybe another element in the collection will have a different organization. And you don't have a contract. Maybe there will be varying type or whatever. So for analysts, if you want to sum up, we have three problems. The language, SQL, the way of thinking about the data organization, collection in one way with imbricated arrays, and table in another way, in another part for the analyst with a table, with relations, and schema. And what they usually do, because the boss asks for an analysis on this data, what they usually do is that they try to hack a pipeline from this MongoDB data to their usual tools. So analysts sometimes use Excel. Like many people use Excel still. And an analyst that uses Excel, what they try to do, maybe they will use SAS and to manipulate the data, to transform it, to flatten it to a Microsoft Access database, and then they can start to use SQL. Other analysts maybe are more data scientists. They know how to code. They use a Jupyter Notebook with Panda to manipulate tables, and scikit-learn to build machine learning models. And this guy, maybe they will try to build a script with PyMongo to ask for data in MongoDB, and then a custom script to flatten the data in CSV file, and then they can start to work. The problem with this way of doing things is that it's a hard job for the analyst. Like, some of them know to code, but usually they do custom solutions that are not stable. And also the problem is that those pipelines are batch. if you want to analyze the data in real time, you cannot do that, so you have to launch the pipeline again. And overall, it's not robust to change, it's difficult to industrialize. So, as we said, this is a common problem because lots of data is in MongoDB and many people want to analyze their data. So there is a solution, obviously. MongoDB Enterprise built a solution, which is commercial, and which is called MongoBI Connector. So it's developed for integration between SQL-based BI tool, like Tableau here, and MongoDB. And what does MongoBI Connector do? It's an SQL compatibility layers. So you have MongoBI Connector in the middle, which talk with MySQL wire protocol inside of the BI tools and allows to work on MongoDB data. I'll go in a little bit in the detail here, but it's not that important. You have two modules in the MongoBI connectors. The first one, the RDL role, is to sample some data, some documents in the collection in MongoDB, and to analyze this document and to find the structure in them, and to present a data model to the BI tool. Another component is responsible to translate the SQL query from the BI tool to MongoDB. So what it does, it's first, it takes the SQL query, it translates it to an aggregation in MongoDB, and then it takes back the result in JSON, post-process it, and send the data in form of the table to the BI tool. So
maybe just one thing to add something here. What is important to understand here in this solution is that you get a dynamic linking between the MongoDB and the BI tool, which means you don't have any data copy, which means you request directly the MongoDB database. And this is one of the main differences between the solution we are going to present afterwards.
Yeah, you have you dynamically interact the data and translate it. So what is good with this solution is that it's official, it's supported, you install it and you use it. Some problems we add with it is that it's commercial, and so you have to pay for the license, the MongoDB Enterprise license. It's closed source, so you don't really, it's a black box, you cannot modify it as you want. We heard that we can have limited performance with it because you have to translate from SQL world to MongoDB world. And also, you have to use MySQL wire protocol, so it's not integrated in every BI tool, so it may be a limitation also. But for us, the main problem was it was commercial, and we have to build an open source analytics stack. Maybe you want to...
I'm going to take the next steps. So we just saw a first solution, which was based on a commercial software. We wanted to have this completely open source stack. So the idea that we had is we want to go from MongoDB to a land where we, data scientists and analysts, are used to work. So we wanted to work with SQL. So we wanted to create a data stream between MongoDB and PostgreSQL. The idea behind that is that once we are in PostgreSQL, we can plug all of our usual tools in it, like the Jupyter Hub, or the different BI tools like Superset or even Tableau. But all the heavy lifting had to be done between these two databases because as we saw earlier, we are talking about two different data structures. And this is done with 3 different open source bricks. We are going to look a bit more into detail in each one of them. The first one is Mongo Connector. The main idea behind this one is simply to synchronize the MongoDB database with another database. Initially, it was developed in order to work with Elasticsearch or Solr or MongoDB, so other NoSQL databases. But what we wanted to do is to find a way to use it with PostgreSQL. It has been open sourced by MongoDB Labs, so there is a very high compatibility with all the different MongoDB versions and also all the Python versions. I want to spend some time here just to explain how it works more precisely. Here you get more or less a typical MongoDB replica set, which means you get one primary node which handles all of the write and read requests, And you've got different secondary nodes, which are more or less here to replicate the data and make sure that even if the first node goes down, there is something here which can take the lead. And if we want to see how it works, this replication, first you get the request which comes here saying, hey, I want to insert a new element, or I just want to update this element. And then you use what we call the uplog file. This guy is just listing all of the different events with the data which is associated. Then the different nodes just have to read this uplog file in order to replicate these changes to their own data model. And what Mongo connector do is simply use this uplog file in order to propagate the changes to other databases. But what is important to understand here is that out of Mongo connector, you don't get directly the requests for the databases. You have to have another layer which is here to translate these requests to a language which is close to the target database. And this is where the doc manager comes in. The main role of this guy is to translate the modification request from Mongo connector to the target database, which means it has to speak the same language. If you're working with a Solar database, you need a Postgre doc manager which is made for that. And we found one which was open sourced by Hopework, and which was specialized to work with PostgreSQL. What is interesting is that this solution or this brick is already in production environment, so it's quite reliable. And we decided to continue and support this solution by contributing to it and adding some QA. I think it's important here to spend some time to really understand how it works, because this is where the heavy lifting is done on how you go from the MongoDB place or the NoSQL place to a more SQL-like place. Let's take a simple example. You get this kind of very classical element in a MongoDB database, which is JSON-like, with all these key value pairs and these nesting elements. And the goal is to go into the MongoDB, in the SQL world, which means tables and columns. For that, you want to map each one of these fields to a column in a table in the SQL. And for that, if you take the first element, it's quite simple. You just add this kind of easy key value pairs. You just map them one-to-one to a column, and it works very well. If you go to a more complicated element, like this dictionary, it also works quite well, in fact, because you still have this one-to-one mapping. You add more columns, but that's okay, and you still get this structure which is respected. But then the complication comes when you get nested elements, which is the case here, where you have this list of arrays for the last field. And in that case, you can't just add more columns behind. It doesn't work. So what you do is you create an another table which is linked to the first one. In this new table, you put the new values. You assign new ideas, but you also assign the parent ID, which is what we call a foreign key. And it's because of this foreign key that we are able to link the two tables together. And that's how you can reconstruct the entire table later. And that's the main work or the main job of this doc manager PostgreSQL.
If we can add something about this schema here, you can see that here we have a list of scalar, an array of scalar. You can also have array of document, and in this array of document, you can have array of document. So you can have many linked table and like that.
Exactly. So you can just add tables to tables to tables to tables. It's very compatible with this kind of structure. So, and what we can see here is that, so we have this mechanism which is able to go from one place to this Mongo place to the SQL place. But what we need is more or less some kind of a mapping file which explains exactly what do we do with this field. And this is the kind of this is the configuration file that the doc manager needs. And you could do this mapping file by hand, just by saying, okay, I want that this field goes here, goes there. But this can be very error prone, especially if you're working with the collections with more than hundreds of fields. So we developed the last brick, which is PyMongo schema, and which objective is for the following. The first one is to scan through the entire database to understand the data model which is lying in the MongoDB database. From this data model schema, you generate the mapping file, which is read by the doc manager and which translates the MongoDB schema. So currently, it's only working with Python 2.7. We are working to make it compatible with Python 3, and we are always very happy if people want to contribute to it. I think we had a lot of elements here. We talked a lot. It could be useful to take maybe a simple use case to really understand how it works and to get things in the easier in the mind. So let's say you're working in a new startup in New York. You're dealing with restaurants, and you get this nice database with all these different restaurants with the cuisine type, the address, list of grades of customers, and you want to do some analytics with that. So, for example, these are the kind of elements you can have, where you get these kind of geolocation coordinates, which are in an array. You get the address. You get a list of grades. So you get these kind of imbricated structure. So this is typical MongoDB data. The first thing you want to do with this stack is use the PyMongo schema brick in order to create or to understand the data model which is in the MongoDB database. For that, you use the extract function, which scans through the entire database and returns the field name and field nesting, the field completion, and also the field type, which is very useful when you are going to do the mapping afterwards. So this is the kind of output that you can get. What you can see, some problem with the screen, but okay. You got the different fields. Normally you should be able to see that there is a difference in the implication. You can see a nesting. But what is very important is that you get the frequency. So you can see that this field has been filled at 100% of time, which is very important for us. So we are able to know if the database is sparse or not. If some fields are filled only 2 or 3%, that's something important for us. And you also get the types. So this is the data model that you have in the database. Once you generate that, you can use the next function, which is to SQL, which simply translates this data model into a mapping file. And this mapping file can be read by the doc manager. This is the kind of mapping file that you have. I won't go into detail. I just want to show some kind of example. This is related to the collection, the database, the restaurant collection. And for simple fields like these ones, you simply say, okay, I want the field which is called cuisine, and I send it to a field which is called cuisine in the new table in the SQL world. So this is very easy to work with. For more complicated fields like address coordinate, where we have this array of scalar, you just say, I send it to a new table which is called restaurant address coord, and where you say exactly what you want to put it, and especially you specify the foreign key here. So this is how you deal with these all the mechanism that we saw earlier, how to go from this nested structure to something which is more flattened with different tables linked together. And once you have this new file, the mapping file given to doc manager, you get the entire pipeline working very well. So you can really have this data stream from MongoDB to PostgreSQL. So as a reminder, Mongo connector check for updates in the uplog file. Afterwards, it sends the update commands with the data to the doc manager, and the doc manager translates these commands to SQL requests. And once you have that, you end up with a very nice SQL structure with all these different tables linked together with the foreign keys. And this is where we, data scientists and analysts, are happy, because we are back in the kind of a world where we are used to. The last thing I wanted to show you is an example or an illustration or what we can do with that. So we have this stack which works very well. We got the data synchronized in the Postgre database, and we can now plug in a new tool. And we want to present you Superset, which is this BI tool which has been open sourced by Airbnb. And we find it very cool to work with, especially in this stack, because these create an entirely open source stack, which help us to do BI and data analysis with MongoDB. So it has been developed to be very easy and intuitive and flexible. And this is the kind of tool you can set up and give to your client or give to managers, because you don't need to have very high technical skills to use it, but you need to know a little bit of SQL if you want to do advanced work. This brick has been open source since I think a few years now. It's still in development, so it's not completely bug-free or glitch-free. There are still some issues with that, but we think that it's still a very good tool, and we are using it in production environments. So maybe you can just go escape. So maybe you can just go to the slices. We are going to create a new visualization. I just want to show you how it works, how you can create all the different dashboards that are very interesting for to produce. So let's say we create a new slice. We choose to. Merci. Okay. Oh, thank you. Teamwork, great. Okay, so let's just create a new slice here, and we want to use the restaurant database. And what is great is that you have a lot of different visualization options. You get classical tables, pivot tables, and different kind of bubble charts, and also heat map. We are going to try just a simple table here. We can do filtering with the date, but that's not something that we want to do right now. And let's say we want just to check the number of restaurants by cuisine type in New York. So you just have to select the right things here and just send the query, and you get all the data here. And you get all the split that you wanted. And this is something which is very easy, and I don't need to know SQL to do this kind of visualization. So this is something that a manager could do, for example. And this is something quite powerful, I would say. Once you've done all of your different visualization, you can gather them into dashboards, and this is what your client would like to have, I guess, because this is something very powerful. You put all the different visualization together. For example, here I got total number of restaurants. I've got the evolution of number of grades through time, different splits by neighborhood or grade type or cuisine, and what is quite cool is that you have this dynamic filtering feature, which means you just click on, for example, Manhattan, if you want to just focus your analysis on this neighborhood. And you also have this kind of cool visualization where with the map, where you can see, for example, here the number of grades per restaurant and their location. So this is something very easy to use for non-technical people. But you can also have a more complicated part or a more technical part where you can use directly SQL requests. That's more for analysts who wants to dig into something very, very specific. And that's where they can have their classical SQL analysis. So that was Superset. So, to wrap up, what we wanted to show you today is that analysts have issues working with NoSQL frameworks. This is due to different reasons. The first one is that NoSQL frameworks are developer-oriented languages, whereas analysts are more used to SQL languages. They are not used to work with nested data structure, like all these imbrication in the different fields. And the fact that we are working with schema-less databases make us work very hard to understand where the data lies and what it's made of. We propose an open source stack to unlock the analysis of MongoDB data. And to do that, we first extracted the MongoDB schema by scanning the entire database. And we normalize the data model, which means we do this flattening where we take the nested data and we put it into different tables linked together with foreign keys, and which enable us to create this real-time synchronization between MongoDB and PostgreSQL. And once we're here, we can plug all the tools that we are used to, and everything works very well. This solution is currently running in production environment, so we are quite happy that it's stable. But what we wanted to say is that don't hesitate to use it, try it, and don't hesitate to contribute if you want to push this solution further. It's open source. And if you have any question, here are our contact information. Thank you.